Hey friends, in our last video we talked about numbers and integers, and now we're going to talk about integer precision because, earlier we divided 11 by 3 and we got the number 3, and that kind of upsets me.
Right.
I want to know where my remainder is, so we're moving on to the next bit of the tutorial, which is integer precision. And they told me that it truncated the result.
Truncated. Now that's a vocab word. That basically just means we lost the remainder.
Okay, so it's gone, which is sad. But what we're going to do is we're going to use a different operator, not the division operator, but we're going to use the modulo operator. So in E, I should get my remainder. Okay, so it's 11 divided by 3. The remainder in this case is 2 because 9 divided by 3 is divides evenly. The remainder is 2. So that's interesting. That didn't give me a decimal or a fraction. It gave me the quotient and the remainder.
Right. Just as if you had worked it out by hand, the remainder would have been 2 at the end.
Now in math, though, integers can kind of go infinitely, though, right? But in C#, there's a minimum and a maximum size for an integer.
Oh, okay. And that's just limited to how much the computer can actually keep in memory in this value type. Because as we said before, integers actually do have constraints when you put them into a computer. So with math on paper, it can often be very theoretical. When you write it down, I could have just an infinite number. With computers, we have real world constraints for how much we can actually save into this processor.
Okay, so let's go and copy this sample and say int.maxValue. Just like we said string.length, it had a property. Integers have properties as well, like min value and max value. And then we'll do the same string stuff that we did in a previous video, and we'll say, let's see the min and the max.
Yeah. Wow.
Oh my goodness.
So it's a pretty big number.
Looks like negative 2 billion.
About that?
Yeah.
Sounds about right.
Yep, 2 billion and a couple of 100 million.
Right.
Between friends. And it's interesting, it's negative to positive, right? So it's it's a 4 billion wide range. And but what if we maybe added 3 to the max?
Yeah, let's see
take
what
max.
happens.
So we have 2 billion, 147 million, and we're going to add 3 to it. Well, that's definitely weird. We said max value plus 3. It flipped the odometer.
Oh, so now instead of going the last few numbers are 647, so it could have gone to 650, it actually just became negative.
So this addition operation overflowed. It's like when you have an old-timey odometer where it goes all the way to 0 and then keeps going.
It just flipped over.
So it wrapped. We were on max, to be clear. We were at the maximum number, which is super high. And now we're at a super tiny number. So something you ought to think about when you're dealing with numbers that are really, really huge. And maybe there are other types with different limits that might be bigger, instead of an integer, a long, or something like that.
Yeah, so you can definitely use larger numbers. It's just at the get-go, you have to make sure you tell your computer that you're going to go above the integer max, so you might want to use a long in that case.
So let's go to the next one. So a numeric type that lets you do a really big number would be a double. And doubles are cool, not just because they're giant, but they're also precise, right? They let you do things with decimal points. And so far, we haven't seen any decimals yet, right? So let's do the exact same thing, right?
Doubles. There we go. There's our remainder. We got 4.5.
Right, and that's a little bit more intuitive. It includes the decimal point. So I didn't have to go and do that modulo stuff, which I found a little bit frustrating. Let's try a more complicated example with doubles. There we go, 5.25. That's good. So what is a double min value and max value?
Oh, yeah.
Is it going to be 2 billion? I don't know. Holy crap.
Oh, wow. So we've got e to the
308 power or whatever.
Yeah, so much, much larger than what integers were limited at.
So that is scientific notation, and that number to the right is that's to the power of, as a power of 10, as an expression as a power of 10. So basically a lot more, to put it in technical terms. So
much more it needs to be printed out in scientific notation. Cool.
And this is an interesting one, too, that you want to think about, because decimals and fractions are slightly different. So if I divide 1 by 3, you'd expect I would get 1/3. But instead I get 0.333333, which is not exactly the same as 1/3, but it's close. It's repeating.
Yeah, it's another case where if you had it on paper, the theory of math is a lot more exact. But again, computers are in the real world, so it has to have some concrete representation of this number, which means ultimately it's rounded at the, 12th decimal place or something like that.
Right. So we've talked about small numbers like integers and really big numbers like doubles. Let's take a break and we'll come back and talk about another kind of number in C#.